Welcome to the deep dive. Today we're jumping into something that, honestly, it sounds a little like science fiction.
But it's actually rooted deep in ancient history.
Exactly. It's a connection that you told us really clicked for you the very first day you started playing around with a tool like ChatGPT,
It did. It sparked this immediate connection in my mind to something called Avadhānaṃ.
which is an ancient Indian literary art form, a kalā.
Right. And so for our deep dive today, our mission is to really map out the parallels, to see just how similar this thousands-year-old art is to modern generative AI.
We're talking ChatGPT, Gemini, even text-to-video like Sora.
And image generators like DALL-E 2. The core question is this. Is modern AI just a technological version of Avadhānaṃ, but, on a massive personalized scale?
I love that idea. A technological replica of an ancient blueprint. So to really understand that, I think we have to start with the original.
We do. We have to decode the Avadhānaṃ event itself.
So what is it? I mean, at its heart.
It's a performance. It's theatrical. It's this dramatic event. And it's all centered on one single person.
The Avadhāni.
The Avadhānaṃ. They are the engine, the ultimate multitasker of the whole show.
So if the Avadhāni is the AI, then the user base, the audience,
They're absolutely critical. They're the puchakas,
the questioners.
the questioners.
Yeah.
And you could almost think of them as the original prompt engineers.
That's a great way to put it. They're defining the tasks and the constraints.
Exactly. And the number of them defines the difficulty.
Right. The source material shows this really clear scaling. You start with something called a tavatana.
Which is 8 concurrent tasks, 8 questioners,
Then it jumps up to satavatana,
100.
100 questioners, and then, and this is just mind-blowing, there are records of sahasravatana,
Which is 1,000 or even more.
1,000 simultaneous challenges for one person. It's a stress test for a human brain.
And it's not just the number of questions. It's the sheer variety, the depth of what's being asked.
What kind of things are we talking about?
Oh, anything. Demands for explanations of classical literature, complex math problems, musical theory.
And all in these very structured, very formal literary languages.
Like Sanskrit, Telugu, or Kannada.
Yeah.
So you need incredibly deep domain knowledge just to start.
Okay, but here is where it gets, for me, really astounding, where the parallel to AI starts to feel so real.
The creative aspect.
Yes, the ojukavitva, spontaneous poetry.
And it's not just write me a poem. A tech arm will give these incredible constraints.
Like what?
Like, compose a poem in this very specific classical meter. It has to start with this syllable and with that one. And somewhere in the middle, you need to include the words elephant, star, ocean, mathematics, and dawn.
Wow.
That level of creative constraint is, it's the key. It's not just making something up.
It's synthesis. It's instantaneous synthesis under incredibly strict rules.
Exactly. You're generating a coherent, beautiful piece of art that has to follow all these formal rules at the same time.
And if that wasn't hard enough, there's this whole other layer.
The distraction layer.
This is what really defines the cognitive load. Because while the Avadhāni is in the middle of composing that poem,
Holding all those rules in their head.
another questioner might just, I don't know, randomly ring a bell or throw flowers at them.
And they have to keep track.
They have to keep a meticulous count of every single bell ring, every flower, while still answering the main question, while still composing the poem.
And remembering every line they've already said and all the other questions from the other 99 people.
So how is that even physically possible?
It's possible because of the training. The Avadhāni has gone through this regimen that basically programs their own biological neural network.
Okay, so that's the perfect bridge. Let's compare that cognitive mastery to the architecture of generative AI.
Let's do it.
So if the brain is the original neural net, how do you train it for that?
The training is all about optimizing these core cognitive functions. You're talking about perfect recall, observation, instant task switching.
The ability to pull information out of your memory at high speed.
Exactly. And to maintain focus, attention and retention, while under extreme pressure. It's decades of structured, rigorous training.
Okay, so now let's contrast that with the generative AI. Its training is something else entirely.
It's the scale of the data. That's the main difference.
Yeah.
The AI's equivalent of that deep knowledge base is the large language model, the LLM. That's what it's trained on.
And while the Avadhāni trains on specific literary classics,
The LLM trains on, it's almost the entire internet. We're talking textual data that can exceed 1 trillion words. Books, articles, websites, forums.
So the sheer volume of knowledge is orders of magnitude larger than any human could ever absorb.
Staggering.
So one is mastery through depth and structure. The other is performance through breadth and data volume.
Precisely. But what's fascinating is that they arrive at a very similar functional capability.
Okay.
And that capability, that's what we see mirrored in the architecture of the generative pre-trained transformer,
Right.
the GPT. The Avadhānaṃ's ability to connect all those different things, the math, the poem, the bell count, is handled in the GPT by something called the self-attention mechanism.
Now that's a term that sounds very technical. Can you give us an analogy for what that's actually doing?
Yeah, of course. Think back to our Avadhānaṃ again, composing that poem while the bell is ringing.
Okay.
At any given moment, their brain has to decide what's most important. Is it the next word of the poem? The meter? The sound of the bell?
It's prioritizing.
It's instant prioritization. The self-attention mechanism does that for every single word. It lets the model weigh the importance of all the other words in the prompt and the conversation to the one it's about to generate.
So that's how it keeps track. That's why when you ask it to write about stars and elephants, it doesn't forget the elephant halfway through.
That's it, exactly. It's continuous, instant, contextual retrieval and prioritization.
So the function is conceptually identical. Whether you're biological or silicon, intelligence is about connecting the right data points instantly under pressure.
It really is. And it raises this interesting point that one achieves it through massive data and algorithms, the other through this dedicated cognitive training.
But the output, what the audience actually sees, that's where the parallels get even crazier.
They do. So let's step away from the internal wiring for a minute.
And just look at the performance. So in Avadhānaṃ, the content is literature, poetry, math, music.
And for generative AI, the performance content is that vast training data, that corpus, which is always growing.
So the first and most obvious parallel in what they do is multitasking.
Clearly, the Avadhānaṃ is all about handling multiple complex questions at once in a set time.
And the AI equivalent is just scaled up. It's not just 10 or 100 questions. It's millions of users at the same time all over the world.
Each with their own complex query, so that many-to-one relationship is still there. It's just amplified beyond imagination.
Okay, what about context retention? You mentioned the distraction handling.
This is maybe the most striking parallel for me. The Avadhānaṃ has to remember every constraint, every question, and count those bells or flowers.
And the AI models do this perfectly.
Perfectly. They track your whole conversation history. They can remember a constraint you set 10 prompts ago. They can count things. They can stick to parameters you set.
It's a mirror of that need for flawless memory and retrieval during the live performance.
It is.
And then there's the highest function of all, creativity, that spontaneous poetry, the ukavitva.
Well, the AI does this through its generative power. You give it a prompt, you give it constraints.
Write a sonnet about quantum physics.
And it just renders it a new poem, following the rules, the meter, the subject, all by drawing on its training.
And now it's happening in languages other than English, too.
It's evolving very quickly to handle complex literature in lots of languages, which really mirrors the multilingual demands on the original Avadhānaṃ.
And this extends way beyond just text, right? I mean, when we look at the new tools.
Absolutely. The functional blueprint is identical.
So something like Sora, the text-to-video model.
Or DLE2 for images. You, the user, give the constraints, the text prompt.
Right.
And the model instantly synthesizes this massive amount of structured data, visuals, motion, rules of composition to create a completely new coherent output.
It's the visual version of what the Avadhānaṃ was doing with words.
It was the ancient art, just replicated with pixels and algorithms. It's incredible.
It really hammers home that this isn't just a loose analogy. It's a functional replication.
Which brings us to the biggest difference of all.
Scale.
Scale and scalability.
The relationship in both is many to one. Many questioners to one Avadhānaṃ, many users to one AI application.
But the capacity is, well, it's fundamentally different.
For the human, the Avadhānaṃ, you're limited by human biology. The absolute peak seems to be around 1,000 simultaneous tasks.
That's the ceiling, the physical and mental limit.
But generative AI, it just shatters that ceiling completely.
It does. The user scalability is humongous. We don't have the exact numbers, but we know these apps are handling tens, maybe hundreds of millions of concurrent requests.
So the functional blueprint, that demand for instant high-context creation, is the same.
It's identical.
But the technology allows for exponential scaling. It's like the fulfillment of an ancient dream.
That's a great way to think about it. The ancient Indian tradition defined this ultimate goal of perfect synthetic knowledge, of instant creation. You could call it the first literary language model.
But it was a model that ran on a person.
Exactly. Modern AI didn't invent the functional need. It just used technology to meet that exact same need and then scale it up for everyone on a personal level.
It's almost like the Avadhānaṃ was a thought experiment, a philosophical concept of what the human mind could potentially do.
And technology just made it real.
That's a really powerful summary. It's just stunning to realize that this ancient pursuit of cognitive mastery finds such a direct mirror in our most complex modern technologies.
It really is.
It makes you think that innovation isn't always about brand new ideas. Sometimes it's about finding new ways to achieve very, very old aspirations.
And that leads to a final sort of provocative thought for you, the listener, to take away from this.
Okay.
The Avadhāni achieved their incredible skill through rigorous, structured, in-depth training. It's a form of personalized cognitive mastery.
Right. Decades of work.
GPT, on the other hand, gets to a similar functional performance using its self-attention mechanism on these massive, mostly unstructured data sets.
So does that comparison point to some kind of universal truth?
That's the question. Is mastery, whether it comes from a human brain or a silicon chip, ultimately just defined by the ability to connect, retrieve, and synthesize huge amounts of information under pressure?
The structure and the speed of connection.
Exactly. And if that function of mastery is constant, if it's the same now as it was 1,000 years ago, what does that mean for how we should be trying to train our own minds today?